the world ends not with fire, but with water. The Great Deluge, a story told in hundreds of cultures across our planet. The Bible speaks of Noah. The Mesopotamians had Utnapishtim. The Greeks remembered Deucalion. But what if these weren't just myths? What if, embedded within these ancient stories, lay fragments of actual memory, traumatic events passed down through generations, whispering of a time when the seas rose not in days, but in decades? Imagine standing at the edge of an ancient coastline 11,600 years ago. The air is crisp, carrying the salt scent of a shore that no human eyes will ever see again. The distant horizon holds no hint of what's coming. You don't realize it, but you're witnessing the end of an era, the terminal phase of the last great ice age. For over 2 million years, ice sheets kilometers thick had locked away vast amounts of Earth's water. But now, something has changed. The planet is warming. And what happens next will redraw the maps of human civilization, submerge entire landscapes, and leave such a profound imprint on our collective memory that we would speak of it for millennia. Welcome to what geologists call Meltwater Pulse 1b, a period around 11,600 years ago when sea levels rose dramatically. Not the biblical 40 days and 40 nights, but something far more insidious, a sustained, relentless advance of the oceans. In places, the coastlines retreated by kilometers every few years. Entire communities vanished beneath the waves. Fertile plains that once supported thousands became seafloor. Islands disappeared entirely, leaving only myths and legends in their wake. This is not speculation. The evidence lies in sediment cores, in ice samples, in the ancient shorelines now hidden beneath our oceans. What remains speculative is how human societies experienced this catastrophic change, and what knowledge was lost when the waters came. Tonight, we embark on a journey through time, piecing together one of humanity's most profound environmental catastrophes. We'll explore the geological evidence for dramatic sea level rise at the end of the last ice age. We'll visit submerged landscapes, entire worlds now hidden beneath the waves. Places like Doggerland, the vast plain that once connected Britain to continental Europe. Now, it lies beneath the North Sea, its secrets slowly being uncovered. In the Persian Gulf, we'll find evidence of a fertile valley, possibly the inspiration for the Garden of Eden, that vanished as the waters rose. Off the coast of India, structures hint at sophisticated settlements now claimed by the Arabian Sea. The questions we face are as vast as the oceans themselves. How quickly did these changes occur? Were they gradual enough for communities to adapt, or did they come as sudden, catastrophic floods, etched into our collective memory as divine punishment? What knowledge was lost? What technologies? What understanding of the world? And most intriguingly, did any advanced civilizations exist in these now submerged coastal regions, their achievements and wisdom lost beneath the unforgiving waves? We know the sea levels rose by approximately 120 meters since the last glacial maximum around 20,000 years ago. But it wasn't a smooth, continuous rise. There were pulses, dramatic accelerations that could transform landscapes within a human lifetime. The most dramatic of these pulses occurred around 14,500 years ago, and again around 11,600 years ago, the latter coinciding with what geologists call the Younger Dryas termination, a period of rapid global warming after a mysterious cold snap. These aren't just academic curiosities. Understanding what happened during these periods of rapid climate change and how human societies responded provides crucial context for our own climate crisis. The past becomes a mirror, reflecting possible futures. Tonight, we separate fact from fiction, evidence from speculation. We'll examine the geological record, archaeological discoveries, and ancient myths to piece together what really happened during humanity's Great Flood, or rather, floods. The journey will take us from the ice cores of Greenland to submerged caves in the Bahamas, from ancient Mesopotamian tablets to cutting-edge sonar maps of the ocean floor. Each piece of evidence offers a glimpse into a lost world. By the end, you'll understand why so many cultures share flood myths. You'll see how rapidly our planet can transform. And perhaps most importantly, you'll gain perspective on humanity's place within Earth's grander climatic cycles. This is not just a story about water. It's about memory, resilience, and how catastrophe shapes the human experience. It's about what happens when the foundations of your world, quite literally, disappear beneath your feet. So join me as we dive beneath the waves, back through time, to explore the truth behind humanity's oldest disaster stories. What really happened during the Great Global Flood? The answer, like so many things from our distant past, lies beneath the surface. Chapter 2. The Drowned Worlds. The numbers are staggering. During certain periods at the end of the last ice age, sea levels rose at rates exceeding 40 millimeters per year. That's 4 centimeters, almost 2 inches, every single year, sustained over decades. To put this in perspective, our current rate of sea level rise due to modern climate change is about 3.7 millimeters per year. What our ancestors witnessed was more than 10 times faster than what we consider a climate emergency today. Imagine living in a coastal community and watching the shoreline creep inexorably closer year after year. Not gradually enough to ignore, but not so rapidly as to force immediate evacuation. A slow-motion catastrophe unfolding across generations. Over a human lifetime of 50 years, the seas would rise by 2 meters, more than 6 feet. Low-lying coastal plains, river deltas, and shallow continental shelves, precisely the environments most attractive for early agricultural settlements, would gradually disappear. What we're discussing isn't merely historical curiosity. It represents a profound reshaping of the human story. The conventional narrative suggests civilization began around 5,000 years ago in Mesopotamia, Egypt, the Indus Valley, and China. But what if this timeline is incomplete? What if earlier centers of human innovation and achievement existed along coastlines that are now submerged under dozens of meters of seawater? The implications would rewrite our understanding of human development. The stakes extend beyond archaeology and history. If sophisticated societies existed earlier than we thought, dealing with their own climate catastrophes, their stories might contain crucial lessons for our own climate emergency. Consider the technologies and knowledge systems we might have lost. Agricultural techniques adapted to changing environments. Social structures designed to relocate entire communities. Maritime technologies capable of navigating changing coastlines and currents. These wouldn't have been primitive societies. By 11,600 years ago, humans had already developed sophisticated art, complex religious systems, long-distance trade networks, and the beginnings of agriculture in multiple locations around the world. The Göbekli Tepe complex in modern Turkey, dating to about 9,600 BC, demonstrates that monumental architecture predated settled agriculture, contradicting long-held assumptions about the development sequence of human civilization. If such sophisticated sites existed on land, what might have been built along the resource-rich coastlines now hidden beneath our oceans? The question isn't idle speculation. It addresses fundamental gaps in our understanding of human prehistory. The timeline presents a compelling mystery. The end of the Younger Dryas around 11,600 years ago marks both a period of rapid sea level rise and the beginning of the Neolithic Revolution, the transition to agriculture in multiple locations worldwide. Is this merely coincidence? Or did rising seas displace coastal populations, forcing them inland with their accumulated knowledge, catalyzing new adaptations to changing environments? The evidence suggests the latter is increasingly plausible. Marine archaeologists have identified over 2,000 submerged prehistoric settlements worldwide. Off the coast of Israel, a submerged settlement called Atlantis contains stone circles, wells, and human remains dating to around 9,000 years ago. In the Bay of Bengal, underwater structures near Mahabalipuram hint at extensive submerged ruins. In Cuba, controversial geometric formations on the seafloor near Guanahacobibe's peninsula suggest possible human structures now under 700 meters of water. The Black Sea flood, around 7,600 years ago, may have inspired Mesopotamian flood myths. Research by marine geologists William Ryan and Walter Pittman revealed evidence of a catastrophic inundation when Mediterranean waters breached the Bosporus. These discoveries force us to confront a startling possibility. What we consider the beginning of civilization might actually represent a rebuilding phase. Cultures recovering from the trauma of substantial land loss and population displacement. The implications extend to our understanding of mythology. Flood stories appear in over 300 distinct cultural traditions worldwide. These aren't just shared narrative tropes. They often contain specific details matching geological events from the early Holocene period. Plato's account of Atlantis, recorded around 360 BCE, describes an advanced civilization on a large island that sank beneath the waves in a single day and night. While embellished through retelling, could it preserve memories of actual submerged landscapes? Aboriginal Australian traditions describe coastal flooding events with remarkable accuracy. Geological confirmation of these stories has verified oral histories maintaining accurate descriptions of coastlines from over 7,000 years ago. The indigenous Haida people of the Pacific Northwest maintain stories of ancient villages now underwater. Marine archaeological surveys have confirmed settlement sites along submerged paleo shorelines, validating these oral traditions spanning thousands of years. What's at stake is nothing less than our understanding of human potential and resilience. If early societies developed sophisticated adaptations to dramatic environmental change, their knowledge could inform our own response to climate crisis. Moreover, if complex civilizations existed earlier than we thought, it challenges our narrative of linear progress. Perhaps human history follows cycles of advancement and regression, tied to environmental changes that periodically reshape our planet. The evidence challenges us to reconsider fundamental assumptions about human history. What if the past 5,000 years, the period we consider historical, represents not the totality of human achievement, but merely the most recent chapter? What if, beneath our oceans, lie the remains of societies that achieved their own forms of technological and social sophistication, adapted to their environments, and ultimately succumbed not to warfare or internal collapse, but to inexorable environmental change? This isn't idle speculation. It's a research question with profound implications for how we understand ourselves and our place in Earth's longer story. The answers lie at the intersection of marine archaeology, paleoclimatology, mythology, and cutting-edge technology. Tonight, we'll explore evidence suggesting that the conventional timeline of human civilization might be incomplete. We'll examine geological records of rapid sea level rise, archaeological discoveries from submerged sites, and cultural memories preserved in ancient myths. By the end, you'll understand why the question of what really happened during the Great Global Flood matters not just for historical accuracy, but for our own society's response to environmental change. The past may hold keys to our future. Chapter 3. The world at the end of ice 11,600 years ago. Our planet was emerging from the grip of the last great ice age. For over 2.5 million years, Earth had been in the cyclic freeze-thaw pattern of the Pleistocene epoch, long glacial periods punctuated by brief warming interglacials. The last glacial maximum occurred around 20,000 years ago. At that time, ice sheets covered much of North America and Northern Europe. The Laurentide ice sheet spread across Canada and the northern United States, reaching heights of over 2 kilometers. In Europe, the Fennoscandian ice sheet blanketed Scandinavia. Similar ice formations covered parts of Siberia, the Himalayas, the southern Andes, and Antarctica. Together, these ice sheets locked away so much water that sea levels stood about 120 meters lower than today. This wasn't the world as we know it. The coastlines extended far beyond their current positions. Indonesia, Malaysia, and the Philippines formed a single landmass called Sundaland. Australia and New Guinea were connected by the land bridge of Sahul. The Persian Gulf was a fertile valley with a river running through it. The English Channel was a vast plain crossed by a river that connected the Rhine and the Thames. The Mediterranean was smaller, with expanded coastlines and additional islands. The Black Sea was a freshwater lake, isolated from the Mediterranean. The Bering Land Bridge connected Siberia to Alaska, allowing humans and animals to migrate between Asia and North America. These were not minor differences. They represented entirely different geographies. Human populations during this period were sparse by modern standards, perhaps 4 million worldwide, but sophisticated in their adaptations. They had already developed complex technologies, art, music, and social structures. The archaeological record from this period shows remarkable achievements. The cave paintings at Lascaux and Chauvet in France, dating to between 17,000 and 30,000 years ago, demonstrate sophisticated artistic techniques and abstract thinking. Stone tools from this period show specialized designs for different purposes: scraping, cutting, drilling, and hunting. Some incorporated composite elements, combining stone, wood, and animal materials with adhesives made from tree resins or bitumen. Humans had already domesticated dogs by this time, the first animal to join our multi-species community. Evidence suggests this partnership began at least 15,000 years ago, providing hunting assistance, protection, companionship, and eventually helping with herding other animals. Long-distance trade networks already existed. Materials like obsidian, amber, shells, and ochre have been found hundreds of kilometers from their sources, indicating exchange systems crossing cultural and geographical boundaries. But around 12,900 years ago, something mysterious happened. After thousands of years of gradual warming, temperatures plummeted across the northern hemisphere. This period, called the Younger Dryas, represented a return to near-glacial conditions that lasted about 1,200 years. The cause remains debated. Leading theories include a massive freshwater influx into the North Atlantic disrupting ocean circulation patterns, possibly from the draining of glacial Lake Agassiz. Others propose a cosmic impact or solar minimum as potential triggers. Whatever the cause, the effects were dramatic. Average temperatures dropped by as much as 15 degrees Celsius, 27 degrees Fahrenheit in some regions. Ice sheets temporarily expanded. Drought conditions spread across much of North America, Europe, and Asia. Plant and animal communities that had been adapting to warming conditions suddenly faced harsh cold. Many species couldn't adapt quickly enough. The Younger Dryas coincides with the extinction of numerous large mammals in North America, including mammoths and giant sloths. Human communities faced severe challenges. Archaeological evidence shows population declines in many regions. Settlement patterns changed as people adapted to new environmental constraints, focusing on reliable water sources and protected locations. Then, around 11,600 years ago, the cold snap ended dramatically. Greenland ice cores show that temperatures rose by as much as 10 degrees Celsius, 18 degrees Fahrenheit within just a few decades. After 1,200 years of deep freeze, the world rapidly warmed. This wasn't a gentle transition. The warming triggered massive ice melt across the remaining glacial formations. Meltwater Pulse 1b began, sending enormous volumes of fresh water into the oceans and raising sea levels at unprecedented rates. Geological evidence shows that during this pulse, sea levels rose by about 20 meters over a period of 500 years. That's an average of 40 millimeters per year, for centimeters annually, with periods of even more rapid rise. For coastal communities, this wasn't an abstract change. It was an existential threat unfolding in real time. Shorelines retreated by hundreds of meters in some areas. Low-lying islands disappeared entirely. River valleys became estuaries. Freshwater marshes turned brackish, then marine. The timing is critical to our understanding of human development. This catastrophic sea level rise occurred precisely when humans in multiple locations were beginning to transition from hunter-gatherer lifestyles to settled agricultural communities. At Abu Huraira in Syria, archaeological evidence shows the transition from hunting gazelle to cultivating rye between 13,000 and 11,500 years ago. In China's Yangtze River Valley, rice domestication began around 11,500 years ago. In the Fertile Crescent, the domestication of wheat, barley, sheep, and goats was underway by 11,000 years ago. In Mesoamerica, squash cultivation began around 10,000 years ago. The timing suggests these developments occurred in response to environmental pressures. What remains less understood is what happened to coastal populations during this time. Modern humans had been exploiting marine resources for at least 160,000 years. Coastal environments offered abundant food, easier transportation, and diverse resources. Logic suggests that during the last ice age, with sea levels 120 meters lower, human populations would have concentrated along those now submerged coastlines. The continental shelves offered flat, fertile landscapes with access to both terrestrial and marine resources. When the waters rose, these communities would have faced progressive displacement. Archaeological evidence becomes increasingly difficult to find as we move offshore into deeper waters, creating a fundamental gap in our understanding of human prehistory. This gap has led some researchers to propose the coastal migration theory, suggesting that significant human developments occurred along these now submerged shorelines. If true, Much of our archaeological understanding of human prehistory may be sampling bias. To truly understand what happened during this critical transition period, we must look beneath the waves. Marine archaeology has begun identifying submerged settlements worldwide, but we've barely scratched the surface of what might lie on the continental shelves. Consider this: approximately 15 million square kilometers of land, an area larger than Europe, was submerged between the last glacial maximum and today. If human populations favored coastal regions as they do now, enormous amounts of evidence remain underwater. Chapter 4. Beneath the surface. First discoveries. The first compelling evidence for sophisticated submerged settlements came in 1984 when fishermen off the coast of Galveston, Texas, pulled up stone tools alongside mastodon remains in their nets. Marine archaeologists investigated and discovered something extraordinary. The site, now called the Galveston Stone Circle, consists of a precise circle of sandstone blocks with a diameter of 18 meters. Located under 12 meters of water on the continental shelf, it was dry land 11,000 years ago. What makes this discovery particularly striking is the precision of the stonework. The blocks appear to have been shaped and arranged deliberately, suggesting human construction rather than natural formation. But who built it and why? Similar stone circles have been documented on land throughout North America, often associated with astronomical observations or ceremonial purposes. Finding one underwater forces us to reconsider our assumptions about the capabilities of pre-agricultural societies. Another breakthrough came in 1997 when marine archaeologist Robert Ballard, famous for discovering the Titanic wreck, was mapping the Black Sea floor. His team discovered an ancient shoreline 155 meters below the current sea level. Analysis of sediment samples revealed something astonishing: a sudden transition from freshwater to marine species. This wasn't a gradual change. It was an abrupt boundary, suggesting the Black Sea had experienced a catastrophic flooding event. Further research by geologists William Ryan and Walter Pittman confirmed that around 7,600 years ago, rising Mediterranean waters breached the Bosporus Strait, sending salt water cascading into the freshwater Black Sea basin at an estimated rate of 200 cubic kilometers daily. The Black Sea's surface would have risen by as much as 15 centimeters per day. Anyone living along the shoreline would have witnessed the waters advancing by more than a kilometer inland every day, a literal biblical-scale flood. This discovery provides compelling geological evidence for a catastrophic flood matching the timeline and location that could have inspired Mesopotamian flood myths, later incorporated into biblical narratives. It connects geological reality with cultural memory, but the evidence extends far beyond the Black Sea. Off India's Gulf of Cambay, now called the Gulf of Cambodge, acoustic imagery has revealed geometric structures covering a vast area. These structures lie under 40 meters of water. Carbon dating of recovered artifacts suggests these structures are at least 9,500 years old, predating the earliest known civilizations in the region by thousands of years. The discovery challenges conventional timelines for urban development in South Asia. The structures appear to include the remnants of a substantial city with clear evidence of urban planning, grid-patterned streets, drainage systems, and large public structures. If confirmed, this would push back the timeline for urban development in South Asia by millennia. In the Mediterranean, off Egypt's Abukir Bay, marine archaeologists have discovered the submerged ruins of Heracleion and Eastern Canopus, once thriving port cities now lying beneath 10 meters of water. Their submergence offers insight into how rising seas affect settlements. These cities were active until around 1,200 years ago, when they gradually sank beneath the waves. Their submergence wasn't due to ice age melt, but to land subsidence combined with rising seas, offering a more recent example of the processes we're discussing. Perhaps the most extensively studied submerged prehistoric landscape is Doggerland, the vast plain that once connected Britain to continental Europe. Now hidden beneath the North Sea, it was gradually submerged between 18,000 and 5,500 years ago. Fishing trawlers have pulled up over 200 archaeological specimens from Doggerland, including worked flints, bone harpoons, human remains, and the bones of mammals including mammoth, reindeer, and wild horse. These indicate substantial human presence. But the most dramatic evidence from Doggerland relates to a catastrophic event around 8,200 years ago. Geological studies show that a massive underwater landslide off the coast of Norway, the Storegga Slide, generated a tsunami up to 10 meters high. This tsunami would have swept across the remaining islands of Doggerland with little warning, potentially wiping out communities that had adapted to the gradually rising seas. It provides a documented example of the kind of catastrophic flooding preserved in cultural memory. The waters off Japan's Yonaguni Island hold perhaps the most controversial underwater structures discovered to date. First observed in 1987, these geometric formations include terrace structures, ramps, and platforms with straight edges and sharp corners. Some marine geologists argue these are entirely natural formations created by the fracturing patterns of sandstone. Others, including underwater archaeologist Masaaki Kimura, contend they show evidence of human modification, potentially dating to around 10,000 years ago. The debate highlights a fundamental challenge in underwater archaeology, distinguishing between natural formations and human constructions, particularly when dealing with sites that may have been submerged for over 10,000 years. In the Bahamas, underwater explorer Graham Hancock has documented enormous stone blocks in regular formations near Bimini. Known as the Bimini Road, these structures have been variously interpreted as natural beach rock formations or artificial constructions. What makes underwater archaeology particularly challenging is that oceanic conditions tend to erode evidence over time. Currents, sediment, marine organisms, and chemical processes all work to obscure human artifacts and structures. This means that what we've discovered so far likely represents only a fraction of what once existed. The most compelling evidence may remain hidden beneath layers of sediment or destroyed by millennia of tidal forces. Additionally, underwater archaeology requires specialized equipment and methodology, making it far more expensive and logistically challenging than land-based excavations. Only recently have technologies advanced sufficiently to enable systematic surveys of submerged landscapes. Side-scan sonar, sub-bottom profilers, ROVs, remotely operated vehicles, and advanced diving equipment have revolutionized our ability to document underwater sites. But these technologies have been widely available for less than 30 years. Consider this perspective. Modern archaeology has been investigating land sites for over 200 years, while systematic underwater prehistoric archaeology is barely 3 decades old. Our understanding of submerged sites remains in its infancy. This technological limitation creates a sampling bias that has profoundly shaped our understanding of human prehistory. We've built our narratives based primarily on evidence from locations that remained above water, potentially missing crucial chapters of the human story. The evidence we've uncovered so far hints at something remarkable: sophisticated human activities in now-submerged coastal regions dating back thousands of years earlier than conventional timelines for complex societies. But the most compelling discoveries may still await us. New technologies are enabling increasingly detailed surveys of the continental shelves. Machine learning algorithms can now detect potential archaeological sites in sonar data that human analysts might miss. As we develop more advanced methods for underwater exploration and excavation, we may be on the verge of discoveries that will fundamentally rewrite our understanding of human prehistory. The conventional narrative may be just the tip of the iceberg. Consider what we might find if we could systematically explore the continental shelves off the coasts of India, Southeast Asia, the Persian Gulf, or the Eastern Mediterranean, all regions where early complex societies are known to have developed. What if the earliest cities lie not in Mesopotamia or the Indus Valley, but on now-submerged coastal plains that offered ideal conditions for the transition to agriculture and urbanization? What if rising seas erased not just settlements, but entire civilizations? The implications would be profound. Our understanding of human development would need fundamental revision. The timeline for technological innovations, social complexity, and cultural achievements would shift dramatically. New questions would emerge. And here lies our greatest cliffhanger. What if the biblical flood and hundreds of similar stories worldwide aren't myths at all, but preserved memories of actual events? What if our ancestors witnessed the drowning of their world and encoded that trauma and story? What if beneath our oceans lies evidence not just of settlements, but of sophisticated societies? with technologies, knowledge systems, and understandings that were lost when the waters rose. What might we learn from these drowned worlds about our own future? As sea levels continue to rise due to modern climate change, understanding how past societies responded to similar challenges becomes increasingly relevant. The lessons from our submerged past may prove crucial for navigating our uncertain future. Chapter 5. Anomalies in the record. What doesn't fit the conventional timeline of human development presents a neat, linear progression. Simple hunter-gatherers slowly developing agriculture around 10,000 years ago, leading to villages, then towns, then cities, and finally civilizations with writing systems around 5,000 years ago. But this orderly narrative faces serious challenges from recent archaeological discoveries. These anomalies don't merely suggest minor adjustments to our understanding. They hint at fundamental misconceptions about humanity's past. Consider Göbekli Tepe in Turkey, a monumental complex of stone circles with T-shaped pillars standing up to 5.5 meters tall and weighing up to 10 tons. The site has been dated to approximately 9,600 BCE, about 11,600 years ago. What makes Göbekli Tepe so anomalous is not just its age, but its sophistication. The pillars feature intricate carvings of animals and abstract symbols, demonstrating advanced artistic capabilities. The construction required coordinated effort from hundreds of workers. Yet Göbekli Tepe was built by people conventionally classified as hunter-gatherers, with no evidence of agriculture, permanent settlements, pottery, or metallurgy, the supposed prerequisites for complex monumental architecture according to traditional archaeological models. This creates a fundamental contradiction. How could supposedly primitive hunter-gatherers organize the labor, expertise, and resources needed to create such sophisticated structures? The site forces us to reconsider our assumptions about prehistoric human capabilities. Even more puzzling, the builders deliberately buried the entire complex around 8,000 BCE, carefully filling in the structures with debris. Why would they invest enormous effort to create monuments, only to intentionally hide them from view? Göbekli Tepe isn't an isolated anomaly. At Gunung Padang in Indonesia, investigations suggest portions of this megalithic site may date back more than 9,000 years, with some controversial dating methods indicating even older origins approaching 20,000 years. Ground-penetrating radar surveys at Gunung Padang reveal multiple layers of construction, with the oldest buried deep beneath the visible surface structures. Carbon dating from deep core samples has produced dates that, if confirmed, would dramatically rewrite Southeast Asian prehistory. In North America, the Cerruti Mastodon site in California presents mastodon bones that appear to have been processed using stone tools. The controversial date, approximately 130,000 years ago, more than 100,000 years before humans supposedly reached the Americas. The Cerruti findings remain hotly contested, but they exemplify a pattern of anomalous discoveries challenging conventional timelines. Similar controversies surround the Chicwa White Cave in Mexico, with artifacts potentially dating to 30,000 years ago. These discoveries share a common theme. They suggest human presence, technological capabilities, or social complexity far earlier than conventional models allow. The question becomes whether these are isolated anomalies or indicators of a fundamentally flawed narrative. But perhaps the most relevant anomalies for our investigation relate to submerged sites. Marine archaeology has identified numerous underwater structures that appear artificial yet date to periods before humans supposedly developed such capabilities. Off Japan's Yonaguni Island, underwater formations include apparent terraces, ramps, and right angles. While some geologists argue these are natural formations, others point to features difficult to explain through natural processes alone. If these are artificial structures, they would have been created when sea levels were lower, potentially more than 10,000 years ago. This timeline contradicts conventional understanding of when complex stone architecture first developed in the region. Similar underwater anomalies have been documented near Malta, Cuba, India, and numerous other locations worldwide. In each case, if the structures prove artificial, they would significantly predate the supposed emergence of such architectural capabilities. A particularly striking example comes from India's Gulf of Khambhat, where acoustic imaging has revealed geometric patterns suggestive of urban layouts now submerged under 40 meters of water. The depth places them at a time before cities supposedly existed. Perhaps most puzzling are stone anchors found on continental shelves worldwide at depths corresponding to ancient shorelines. These anchors suggest maritime capabilities far earlier than conventionally acknowledged, including deep-sea navigation. When we examine ancient harbors on current coastlines, we often find multiple construction phases at different elevations, successively higher installations built to accommodate rising sea levels throughout recorded history. These sequential harbor constructions provide physical evidence of communities adapting to changing sea levels during historical times. But what of the earlier, more dramatic sea level changes? Where are the harbors from the early Holocene? The answer, logically, is that they now lie underwater. But this creates another anomaly. If prehistoric coastal communities possessed harbor construction capabilities, they must have had maritime technologies more advanced than conventionally credited to them. The underwater evidence creates a challenging paradox. We have potential architectural remains suggesting sophisticated capabilities, yet they date to periods when humans supposedly lacked such technologies. How do we resolve this contradiction? One possibility is that conventional dating methods have produced incorrect results for these underwater sites. Perhaps they are younger than they appear, representing known civilizations whose remains have been submerged by local geological processes. But another possibility is more provocative. What if human technological and social development followed a different pattern than our conventional models suggest? What if coastal populations achieved greater sophistication earlier than inland communities? This earlier coastal complexity hypothesis would explain why evidence for advanced prehistoric societies remains elusive. It's underwater. Our archaeological record would be fundamentally biased toward inland sites that remained above sea level. The hypothesis gains support from what we know about resource availability. Coastal environments provide exceptional resource density, combining marine proteins, freshwater from river mouths, fertile alluvial soils, and natural transportation networks. These advantages would have made coastal zones prime locations for early population centers. Logic suggests human innovation might have progressed faster in these resource-rich environments than in the more challenging inland areas. When sea levels rose dramatically at the end of the last ice age, these hypothetical coastal centers would have faced existential threats. Communities would have been forced to relocate inland, abandoning settlements, infrastructure, and potentially knowledge systems. The archaeological record shows curious technological regressions at various points in prehistory, periods when sophisticated techniques appear to have been forgotten. Might these represent the aftermath of coastal displacement events? For example, the sophisticated maritime capabilities evident in the Pacific island settlements appear to have developed remarkably quickly around 3,000 years ago. Might this represent not new innovation, but the rediscovery of older nautical technologies? Similarly, the seemingly sudden emergence of complex societies in Mesopotamia, Egypt, and the Indus Valley around 5,000 years ago might represent not the first instance of such development, but a recovery phase after earlier coastal civilizations were displaced. These possibilities force us to confront a fundamental limitation in our understanding of human prehistory. The absence of evidence is not evidence of absence, particularly when vast potential archaeological zones remain largely unexplored beneath the waves. What we're identifying isn't just a few anomalous sites, but a pattern suggesting our entire framework for understanding prehistoric human development might be based on incomplete data, the archaeological equivalent of trying to understand a book by reading only its final chapters. The anomalies point toward a provocative possibility. What if the cradle of civilization wasn't in Mesopotamia, Egypt, or China, but on coastal shelves that now lie dozens of meters underwater? What if we've been looking in the wrong places? Chapter 6. Memories and Myth. When stories preserve truth throughout human history, myths and legends have served as vessels for cultural memory, transmitting crucial information across generations. Modern scholars often dismiss these as mere fantasies or symbolic narratives. Yet recent archaeological discoveries have validated many ancient stories once considered fictional. Troy was considered mythical until Heinrich Schliemann discovered its ruins in the 1870s. The Minoan civilization seemed legendary until Arthur Evans unearthed Knossos on Crete. Time and again, myths have proven to contain kernels of historical truth. Flood myths deserve particular attention in this context. They appear in over 300 distinct cultural traditions worldwide, spanning every inhabited continent. While superficially different, they share remarkable similarities in their core narratives. In these stories, divine forces send waters to cleanse the world of corruption or wickedness. A righteous individual receives warning and builds a vessel. After the flood subsides, this survivor becomes the progenitor of renewed humanity. The biblical account of Noah is perhaps the most familiar to Western audiences, but similar narratives appear in Hindu traditions with Manu, in Mesopotamian epics with Utnapishtim, in Greek mythology with Deucalion and Pyrrha, and in countless indigenous oral histories. What makes these parallels significant is not just their thematic similarity, but specific details that recur across geographically dispersed cultures with no known historical contact. These common elements suggest either universal psychological patterns or shared historical experiences. The conventional explanation attributes these similarities to universal human experiences with local flooding events. But this fails to account for the global distribution and remarkable consistency of these narratives across diverse environments, including regions where catastrophic floods are rare. A more compelling hypothesis emerges when we align these myths with the geological record of post-glacial sea level rise. The timing and magnitude of these events could have generated exactly the kind of world-changing flood experiences preserved in global mythology. Consider the Haida people of the Pacific Northwest, whose oral traditions describe ancient villages now underwater. Marine archaeological surveys have confirmed settlement sites along submerged paleo shorelines exactly where their stories indicated they would be. Australian Aboriginal traditions describe coastal flooding events with remarkable geographical precision. When these accounts were compared with bathymetric maps showing the contours of submerged landscapes, the correspondence was striking. These traditions had accurately preserved coastline configurations from over 7,000 years ago, passed down through hundreds of generations without writing. This demonstrates how resilient oral traditions can be when they convey survival-critical information. Similar validations have occurred with indigenous traditions in India, Southeast Asia, and the Mediterranean. In each case, stories once dismissed as fantasies have been confirmed through geological and archaeological evidence as containing authentic historical memories. Beyond flood myths, other anomalous traditions hint at sophisticated ancient knowledge. Sumerian and Babylonian astronomical texts describe planetary details supposedly beyond their observational capabilities, including accurate knowledge of distant celestial bodies. The Dogon people of Mali possess detailed knowledge about the Sirius star system, including information about Sirius B, a white dwarf star invisible to the naked eye. How they obtained this knowledge remains a subject of debate. Ancient Sanskrit texts describe technologies resembling batteries, aircraft, and even nuclear weapons. While often dismissed as fantastical, some researchers point to potential technological artifacts like the Baghdad battery as evidence that ancient technical knowledge may have exceeded conventional estimates. The Antikythera mechanism, discovered in a 2,000-year-old shipwreck, demonstrates astronomical computing capabilities far beyond what historians believed possible for that era. Its sophistication suggests it wasn't a unique invention, but part of a developed technological tradition. These examples force us to confront a challenging question. What other authentic historical information might be preserved in myths and legends we've dismissed as mere stories? What if these narratives contain crucial clues about lost episodes of human history? Plato's account of Atlantis deserves reconsideration in this context. While embellished with moral and philosophical elements, the core narrative describes an advanced island civilization destroyed by flooding in a single day and night of misfortune. Plato claimed the story came from Egyptian priests who maintained records from 9,000 years before his time, placing the events around 11,600 years ago. This timing coincides precisely with Meltwater Pulse 1b and the end of the Younger Dryas period. The location Plato describes, beyond the Pillars of Hercules, the Strait of Gibraltar, has prompted speculation about various Atlantic locations. However, rising sea levels would have inundated numerous Mediterranean islands during this period as well. The Atlantis narrative gains credibility when considered alongside geological evidence for catastrophic flooding events around this time. The Black Sea deluge, Mediterranean basin flooding through the Strait of Gibraltar, and collapse of ice dams in North America all occurred during this general period. Another category of evidence comes from what archaeologists call out-of-place artifacts, objects discovered in geological contexts that challenge conventional chronologies. These findings are often controversial precisely because they don't fit established narratives. The London hammer, discovered in London, Texas, consists of a wooden-handled iron hammer encased in rock dated to the Ordovician period, over 400 million years ago. While skeptics suggest the dating is flawed, the artifact remains difficult to explain conventionally. The Antikythera mechanism, while not nearly as temporally anomalous, still represents technology that appeared too early according to conventional understanding. Its sophisticated gear system demonstrates astronomical computing capabilities supposedly beyond its era. Ancient maps present another category of anomalous evidence. The Piri-Reis map, compiled in 1513 from older source maps, appears to show Antarctica's coastline without ice, a configuration that hasn't existed for thousands of years. The Orance Fine map of 1531 similarly depicts Antarctic coastal features now hidden beneath ice sheets. Studies by the U.S. Air Force in the 1960s concluded these maps show Antarctica as it would have appeared over 6,000 years ago. If these maps were copied from much older originals, they suggest sophisticated geographical knowledge and global mapping capabilities long before such technologies were supposedly developed. This would require both advanced mathematics and extensive maritime exploration. Perhaps the most compelling out-of-place evidence comes from underwater structures. Stone anchors found on continental shelves at depths corresponding to Ice Age shorelines suggest maritime capabilities far earlier than conventionally acknowledged. Off the coast of Yonaguni, Japan, underwater rock formations include straight edges, right angles, and apparent stairs and terraces. While natural explanations have been proposed, some marine geologists argue these show evidence of human modification. Similar underwater anomalies have been documented worldwide. In India's Gulf of Khambhat, side-scan sonar has revealed geometric patterns resembling street grids now submerged under 40 meters of water. Initial dating suggests these structures are at least 9,000 years old. Near Cuba's west coast, sonar imaging has identified geometric structures under hundreds of meters of water. If artificial, their depth would place their construction during the last ice age, tens of thousands of years before complex societies supposedly emerged. These underwater discoveries face greater skepticism than their terrestrial counterparts because they're more difficult to investigate and date. But their potential implications are profound. They could represent the remains of sophisticated maritime civilizations predating conventional historical timelines. When we combine these lines of evidence, global flood myths, validated indigenous traditions, anomalous artifacts, ancient maps, and underwater structures, a pattern emerges suggesting our understanding of prehistoric human capabilities may be fundamentally incomplete. The question becomes whether these represent isolated anomalies requiring individual explanation or coherent evidence for an alternative historical narrative, one in which sophisticated coastal civilizations developed earlier than conventionally acknowledged, only to be displaced or destroyed by rising sea levels. Chapter 7. The Submerged Memory, when history gets erased. When sea levels rise catastrophically, they don't just claim land, they erase history. Entire cultural landscapes disappear, taking with them the physical evidence of human achievement. What remains are fragments, scattered artifacts, disrupted communities, and stories that gradually transform into myths. We tend to think of historical amnesia as a modern phenomenon, the product of book burning, ideological purges, or technological obsolescence. But the most effective eraser of human memory has always been water, rising, inexorable, and indifferent to human achievement. Consider what happens when a coastal community faces inundation. Initially, they might build seawalls or relocate structures to higher ground. As waters continue rising, they eventually abandon the settlement entirely, salvaging what they can carry. The heaviest items, stone monuments, massive buildings, infrastructure, remain behind, eventually submerged. Knowledge systems tied to specific landscapes, agricultural techniques, astronomical alignments, navigational landmarks, become irrelevant in new environments. Specialized technologies adapted to coastal environments, harbor facilities, fishing systems, sea transportation may become unusable in inland settings. The knowledge to create them fades if not immediately applicable to survival in the new location. Social structures designed around maritime resources and transportation networks face disruption. Leadership hierarchies, trade relationships, and cultural practices may collapse during the displacement process. What emerges inland may bear little resemblance to what existed before. This pattern of disruption followed by adaptation represents more than simple relocation. It constitutes cultural transformation under existential pressure. The archaeological signature would show apparent technological regression followed by novel adaptations. When we examine the archaeological record through this lens, curious patterns emerge. Throughout prehistory, we see instances of sophisticated technologies appearing to vanish, followed by periods of apparent regression, then gradual recovery and new innovation. The collapse of Bronze Age Mediterranean civilizations around 1200 BCE exemplifies this pattern on a regional scale. Complex urban societies with international trade networks, writing systems, and advanced metallurgy seemingly collapsed, followed by centuries of reduced complexity. While traditionally attributed to sea peoples' invasions or internal failures, recent evidence suggests environmental factors, including changing sea levels and climate instability, played crucial roles in this systemic collapse. Similar patterns appear at the end of the last ice age. As Meltwater Pulse 1b inundated coastal plains worldwide between 11,600 and 11,000 years ago, we see evidence of population displacement, technological disruption, and cultural transformation. The stakes of understanding these processes extend beyond historical curiosity. They speak to fundamental questions about human resilience, adaptability, and the fragility of knowledge systems under environmental pressure, questions directly relevant to our current climate crisis. If sophisticated coastal civilizations existed during the early Holocene, their inundation wouldn't just represent lost settlements, but potentially lost knowledge, technologies, social organizations, and adaptations that might have taken millennia to develop. The implications become particularly significant when we consider apparent technological anomalies in the archaeological record, instances where sophisticated capabilities seem to appear fully formed, without clear developmental precursors. For example, the emergence of monumental architecture at sites like Göbekli Tepe seems to occur with minimal precedent. The sophisticated astronomical knowledge embedded in ancient structures worldwide appears with remarkable precision seemingly from nowhere. Maritime technologies capable of transoceanic voyages appear in the archaeological record already perfected. The sophisticated mathematical knowledge underlying ancient calendar systems emerges fully developed. Certain medical procedures appear with unexpected precision. Conventional explanations attribute these apparent leaps to incomplete archaeological sampling, assuming developmental stages existed but haven't been discovered. But an alternative explanation becomes possible when we consider the submerged landscape. What if these weren't spontaneous innovations, but technologies preserved from earlier coastal societies? What if they represent not the beginning of development sequences, but the recovery of knowledge partially lost during displacement events? This disrupted knowledge transmission hypothesis gains credibility when we examine indigenous oral traditions worldwide. Many explicitly describe technological and cultural losses following displacement from ancestral coastal territories. Aboriginal Australian traditions describe not just the flooding of ancestral lands, but specific knowledge tied to submerged landscapes, astronomical alignments, resource management systems, and navigational techniques that became compromised when landmarks disappeared beneath the waves. Pacific Island navigation traditions explicitly reference forgotten knowledge, describing more extensive voyaging networks that contracted following some unspecified catastrophe, with only fragments of the original knowledge system surviving. Native American traditions along the Atlantic and Pacific coasts contain similar themes, describing more extensive maritime capabilities in the ancestral past that diminished following coastal changes. These narratives suggest technological regression rather than continuous progress. The evidence becomes more compelling when we examine the global distribution of certain technological systems. Megalithic architecture, for instance, appears almost simultaneously around the world's coastlines following the stabilization of sea levels around 7,000 years ago. From Malta to Japan, coastal Peru to the British Isles, megalithic traditions share striking similarities in construction techniques, astronomical alignments, and even symbolic systems. These commonalities suggest either independent parallel development or some shared ancestral tradition. The latter possibility, that megalithic traditions worldwide represent the fragmented recovery of earlier architectural knowledge, becomes more plausible when we consider that all emerged following the same global environmental disruption, post-glacial sea level stabilization. A similar pattern appears with ancient measurement systems. Seemingly unconnected civilizations worldwide used measurement standards based on remarkably precise astronomical values. These include the Egyptian royal cubit, the Mesopotamian Kush, and measurement systems in ancient India and China. The coincidence that multiple civilizations independently developed nearly identical measurement standards based on the same astronomical principles stretches credibility. A more parsimonious explanation might be that these represent preserved fragments of a shared earlier knowledge system. Ancient agricultural practices show comparable patterns. Sophisticated water management systems, crop rotation techniques, and soil conservation methods appear in multiple locations with minimal developmental precursors. Many incorporate knowledge requiring centuries of systematic observation. These patterns suggest an alternative historical model. What if human technological and social development hasn't followed a simple linear progression, but rather a more complex cycle of advancement, disruption, fragmentation, preservation, and recovery? In this model, rising sea levels at the end of the last ice age wouldn't just have displaced populations, but disrupted knowledge transmission systems, fragmenting previously cohesive cultural traditions and technological capabilities. What survived would have been portions of knowledge systems, those aspects most critical for immediate survival or most easily preserved through oral transmission. More complex or specialized knowledge might have been lost or preserved only in isolated pockets. This model helps explain both the apparent missing prehistory problem and the curious distribution of sophisticated knowledge in ancient civilizations. It suggests our conventional historical narrative might begin not at the beginning, but in the middle of a much longer story. The stakes of this alternative understanding extend beyond academic curiosity. If prehistoric societies achieved substantial technological and social complexity, only to face catastrophic disruption from environmental change, their experiences might hold crucial lessons for our own civilization. We currently face accelerating sea level rise due to anthropogenic climate change. While proceeding more slowly than Meltwater Pulse 1b, current projections suggest coastal inundation affecting hundreds of millions of people within the coming century. Understanding how earlier societies responded to similar challenges, what knowledge they preserved, what they lost, and how they reorganized, could provide vital context for our own adaptation strategies. The submerged past becomes a mirror reflecting possible futures. Moreover, if sophisticated maritime civilizations existed earlier than conventionally acknowledged, they might have developed adaptations specifically designed for changing coastal environments. This potentially lost knowledge could prove invaluable as we face similar challenges. The mystery deepens when we consider specific technological losses that appear in the historical record. Techniques for quarrying and transporting massive monoliths, for instance, seem to have been forgotten and reinvented multiple times throughout history. Certain astronomical knowledge appears to have degraded over time rather than progressively improved. The architectural precision of the oldest Egyptian pyramids exceeds that of later examples. Specific metallurgical techniques disappeared only to be rediscovered centuries later. These instances of lost knowledge challenge our assumption of continuous technological progress. They suggest more complex historical processes where catastrophic disruptions could result in significant knowledge lost despite human efforts at preservation. Which brings us to the most provocative question. What if the mythic golden ages described in numerous ancient traditions weren't purely imaginative, but contain memories of actual advanced societies that collapsed under environmental pressure? What if these weren't just stories but encoded warnings about the fragility of human achievement in the face of environmental change? What if they represent attempts to preserve crucial knowledge through the vehicle of narrative when physical evidence disappeared beneath the waves? And perhaps most importantly, what if we're currently rediscovering, through underwater archaeology and advanced sensing technologies, evidence of these lost chapters in human development? What might we learn from these drowned worlds about our own future? As we continue our exploration, the evidence becomes increasingly compelling. Off the coast of Israel, divers recently discovered a 9,000-year-old settlement with intact stone walls, dwellings, hearths, and human burials, a complete Neolithic village preserved under the Mediterranean. Near the island of Pavlopetri off Greece's southern coast, archaeologists have mapped an entire submerged Bronze Age town with streets, buildings, and tombs dating to at least 5,000 years ago. The site demonstrates how perfectly underwater archaeology can preserve ancient landscapes. In India's Gulf of Cambay, recovered artifacts from submerged sites include pottery, hearths, beads, sculpture fragments, and human remains. Carbon dating places these materials between 5,000 and 9,500 years ago, far earlier than urban civilizations supposedly developed in the region. Each of these discoveries reinforces a challenging reality. The majority of human prehistory likely occurred in coastal environments that now lie underwater. Our understanding, based primarily on inland sites, may represent not the main story, but the periphery. What else might we find as exploration continues? Could there be evidence of maritime technologies far more advanced than conventionally believed? Might we discover writing systems that push literacy back thousands of years earlier than currently acknowledged? Could submerged sites reveal astronomical observatories predating Stonehenge by millennia? Might we find evidence of long-distance trade networks connecting disparate regions during the early Holocene? Could sophisticated urban planning exist thousands of years before Mesopotamia? As underwater exploration technologies continue advancing, we stand on the threshold of potentially revolutionary discoveries. The conventional narrative of human prehistory, with all its neat categorizations and linear progressions, may be on the verge of fundamental revision. And this brings us to our central mystery. If sophisticated maritime civilizations existed during the early Holocene, were subsequently displaced by rising seas, and left behind only fragments of their knowledge and achievements, how would we know? What evidence would survive? The answer may lie in a combination of underwater archaeology, indigenous oral traditions, anomalous artifacts, and curious technological leaps in the conventional record. Together, these lines of evidence point toward a compelling possibility. Our understanding of human prehistory may be profoundly incomplete. Chapter 8: Competing Theories: What Really Happened? After examining the geological evidence for sea level rise, underwater archaeological discoveries, and cultural memories preserved in global mythology, we face a pivotal question. What actually happened during the Great Floods at the end of the last ice age? Several compelling theories have emerged. The first and most conservative interpretation, the gradual adaptation theory, suggests that sea level rise, while significant, occurred slowly enough that coastal populations simply migrated inland over generations, gradually adapting their technologies and social structures to new environments. In this model, sea level rise occurred at an average rate of 1 to 2 meters per century, rapid in geological terms, but slow enough in human time frames that communities could relocate without catastrophic disruption. Knowledge transmission remained largely intact despite displacement. Proponents point to archaeological evidence showing gradual cultural transitions during this period rather than abrupt collapses. They note that many inland Neolithic sites show evidence of maritime knowledge, suggesting successful transfer of coastal technologies during migration. The gradual adaptation theory aligns with conventional archaeological frameworks. It requires no radical revision of human prehistory, merely acknowledgement that significant population centers existed on now-submerged continental shelves, with their inhabitants eventually relocating inland. What we know is that sea levels rose approximately 120 meters since the last glacial maximum. Archaeological evidence confirms human settlements on now-submerged coastlines. The gradual adaptation model suggests these communities successfully relocated with minimal cultural disruption. What remains uncertain is whether the pace of sea level rise remained consistently gradual. Geological evidence indicates periods of accelerated rise, meltwater pulses, when coastlines could retreat by kilometers within a single human lifetime. A more dramatic alternative, the catastrophic displacement theory, suggests these meltwater pulses created genuinely catastrophic flooding events that overwhelmed human adaptive capabilities, resulting in significant population loss and cultural disruption. This theory points to evidence from Meltwater Pulse 1b, which saw sea levels rise 14 to 18 meters in less than 500 years around 11,600 years ago. In certain coastal regions with shallow continental shelves, this could have caused shorelines to retreat by kilometers every decade. Such rapid inundation would have overwhelmed attempts at gradual relocation. Communities would face sudden displacement, loss of resource bases, and potential conflict with inland populations as they sought new territories. Knowledge systems could fragment under such pressure. Proponents of this theory point to apparent technological regression visible in the archaeological record following these meltwater pulses. They note curious, dark ages where sophisticated techniques seem to disappear, followed by periods of rediscovery and innovation. They also highlight the emotional power and ubiquity of flood myths worldwide. These narratives universally describe catastrophic rather than gradual flooding, consistent with the experience of communities facing accelerated sea level rise during meltwater pulses. What we know is that meltwater pulses occurred at the end of the last ice age, with sea levels rising at rates up to 40 millimeters per year during peak periods, 10 times faster than current sea level rise. These rates would have created observable shoreline changes within a human lifetime. What remains uncertain is how these physically rapid changes would have been experienced culturally. Would communities have maintained social cohesion during displacement? Would knowledge transmission systems have remained intact? Or would critical information have been lost? A third, more speculative theory, the advanced maritime civilization hypothesis, suggests that sophisticated coastal civilizations had developed by the early Holocene, only to be disrupted or destroyed by rising seas during meltwater pulses. This hypothesis proposes that maritime societies developed along productive coastlines during the relatively stable periods of the late Pleistocene, achieving greater technological and social complexity than conventionally acknowledged for hunter-gatherer populations. Proponents point to anomalous underwater structures, sophisticated astronomical knowledge in ancient cultures, and the seemingly sudden emergence of complex technologies in the archaeological record as evidence for earlier advanced societies whose remains now lie underwater. They note that coastal environments provide ideal conditions for technological innovation. Abundant food resources reducing subsistence pressure, natural transportation networks facilitating knowledge exchange, and diverse ecosystems encouraging adaptive problem-solving. The hypothesis suggests these societies developed specialized maritime technologies, astronomical knowledge for navigation, mathematical systems, and potentially writing or proto-writing systems, achievements traditionally associated with much later agricultural civilizations. When sea levels rose dramatically during meltwater pulses, these hypothetical societies faced existential threats. Some populations would have relocated successfully, preserving portions of their knowledge. Others may have collapsed entirely, their achievements lost to history. What we know is that humans have repeatedly demonstrated remarkable capacity for innovation when environmental conditions permit. Coastal environments would have provided ideal conditions for such innovation during the late Pleistocene and early Holocene. What remains speculative is whether these conditions actually produced societies significantly more advanced than conventional models suggest. While intriguing underwater anomalies exist, definitive evidence of advanced early Holocene civilizations remains elusive. Each of these theories, gradual adaptation, catastrophic displacement, and advanced maritime civilization, offers a different interpretation of the same evidence. They exist on a spectrum from conservative to radical in their implications for human prehistory. The gradual adaptation theory requires minimal revision to conventional understanding. It simply acknowledges that significant human activity occurred on now-submerged coastlines, with populations successfully relocating as seas gradually rose. The catastrophic displacement theory suggests more significant disruption, with rapid sea level rise creating genuine catastrophes that fragmented communities, disrupted knowledge transmission, and potentially caused significant population loss. The advanced maritime civilization hypothesis proposes the most radical revision, suggesting sophisticated societies achieved technological and social complexity thousands of years earlier than conventionally acknowledged. only to be disrupted by rising seas. Determining which theory best explains the evidence requires careful evaluation of multiple disciplines: geology, archaeology, comparative mythology, paleoclimatology, and genetic studies of ancient population movements. Geological evidence confirms that sea level rise occurred in pulses rather than at constant rates. During Meltwater Pulse 1b around 11,600 years ago, seas rose 14 to 18 meters in less than 500 years, fast enough to observe changes within a human lifetime. Archaeological evidence increasingly confirms sophisticated human activity on now submerged coastlines, with underwater sites revealing complex structures, tools, and settlement patterns dating to the early Holocene and late Pleistocene. Genetic studies show population bottlenecks and migration events coinciding with periods of rapid sea level rise, suggesting significant demographic disruption. Ancient DNA reveals population replacements and migrations consistent with coastal displacement. Comparative mythology provides compelling evidence for cultural memory of flooding events, with remarkably similar narratives appearing in geographically dispersed traditions. These consistently describe catastrophic rather than gradual flooding. When considered together, these lines of evidence suggest the middle theory, catastrophic displacement, most accurately describes what happened during the Great Floods at the end of the last ice age. While evidence for truly advanced maritime civilizations remains inconclusive, the geological record clearly shows sea level rise occurred rapidly enough during meltwater pulses to create genuinely catastrophic conditions for coastal populations. These catastrophes would have forced sudden displacement, disrupted subsistence patterns, fragmented social structures, and potentially led to conflict with inland populations. Knowledge transmission would have been compromised, with some technologies and cultural practices lost. The resulting population movements, technological disruptions, and cultural transformations would have been sufficiently traumatic to embed themselves in oral traditions worldwide, eventually evolving into the flood myths that appear in hundreds of cultures. This understanding doesn't require speculative, lost civilizations to explain the evidence. It simply acknowledges that coastal populations experiencing catastrophic flooding would have faced severe challenges to cultural continuity and knowledge preservation. It also explains apparent technological regressions in the archaeological record, not as evidence of advanced civilizations collapsing, but as the natural consequence of specialized coastal knowledge becoming less relevant or lost entirely during rapid displacement. Most importantly, this middle ground interpretation aligns with both scientific evidence and indigenous oral traditions. It acknowledges the reality of catastrophic flooding events while remaining grounded in the archaeological and geological record. As we continue exploring underwater sites, our understanding will inevitably evolve. New discoveries may shift the balance toward more conservative or more radical interpretations. The investigation remains ongoing, with crucial evidence still hidden beneath the waves. Chapter 9: The New Science of Drowned Worlds. Recent advances in underwater archaeology have revolutionized our ability to investigate submerged landscapes. Technologies developed primarily for oil exploration and military applications have been repurposed to reveal the hidden topography of the continental shelves. Multi-beam sonar can now map the seafloor with centimeter-level precision, revealing ancient river valleys, lake beds, and potential settlement sites. Sub-bottom profilers penetrate sediment layers to show structures buried beneath the seafloor. Remote-operated vehicles, ROVs, equipped with high-definition cameras, can survey underwater sites at depths beyond human diving capabilities. Core sampling technologies extract sediment sequences, preserving environmental and archaeological data spanning thousands of years. Perhaps most revolutionary, LiDAR, light detection and ranging, technology can penetrate shallow waters to reveal submerged landscapes with extraordinary detail. Recent LiDAR surveys have mapped entire prehistoric landscapes, now hidden beneath the waves. Off the coast of Florida, LiDAR has revealed a 9,000-year-old hunting site complete with stone structures arranged in patterns seemingly designed to corral animals. Prehistoric hunting infrastructure now under 5 meters of water. In the Mediterranean, detailed underwater mapping has revealed an extensive network of submerged Neolithic villages along what were once lockshores in central Turkey. These sites contain stone foundations, hearths, and activity areas preserved exactly as they were abandoned. In the Black Sea, remote-operated vehicles have documented dozens of shipwrecks preserved in the oxygen-free deep waters. These include vessels dating from Byzantine times back to the Bronze Age, a maritime archaeological record of unprecedented completeness. Off Britain's coast, the Britain's Atlantis project has mapped over 20,000 square kilometers of Doggerland, revealing a complex landscape of hills, rivers, lakes, and marshes that once connected Britain to continental Europe. These investigations reveal not just the physical landscape, but evidence of how humans exploited it. Preserved footpaths follow ancient ridgelines. Fishing structures align with tidal channels. Settlements cluster at river confluences, the infrastructure of maritime economies now submerged. The most startling discoveries combine underwater archaeology with paleoclimatology to reconstruct not just the submerged landscape, but how rapidly it changed. This approach has revealed evidence for catastrophic flooding events preserved on the continental shelves. In the Persian Gulf, sediment cores show a sudden transition from terrestrial to marine environments around 8,000 years ago. Analysis indicates the flooding occurred rapidly enough to leave prehistoric campsites intact on the seafloor, their occupants having fled without collecting their belongings. In the Bay of Bengal, similar evidence shows rapid inundation of the continental shelf. Intact stone structures now under 20 meters of water suggest flooding occurred quickly enough that communities couldn't dismantle and relocate their built environment. These findings present a paradox for archaeological interpretation. The conventional view holds that complex stone architecture didn't develop until after 7,000 years ago. Yet underwater sites push this timeline back by millennia. Even more challenging are potential structures found at depths corresponding to much earlier periods. If artificial, formations off Japan, Malta, and India would have been created when sea levels were 40+ meters lower, over 10,000 years ago. This creates a fundamental conflict with conventional chronologies of human technological development. Either these structures aren't artificial, despite their geometric properties, or human architectural capabilities developed far earlier than traditionally acknowledged. Recent findings from terrestrial sites compound this paradox. Göbekli Tepe in Turkey features massive stone pillars with sophisticated carvings created 11,600 years ago by people conventionally classified as hunter-gatherers without metallurgy or even pottery. At Gunung Padang in Indonesia, controversial investigations suggest artificial structures buried under a known megalithic site may date back more than 10,000 years. Ground-penetrating radar reveals multiple construction phases, with the oldest deeply buried. In both cases, conventional archaeological frameworks struggle to explain how supposedly primitive hunter-gatherer societies could organize the labor, expertise, and resources needed for monumental construction on this scale. A potential resolution to this paradox emerges when we consider the implications of submerged landscapes. What if coastal populations achieved greater technological and social complexity earlier than inland groups due to their advantageous environmental conditions? Coastal zones provide exceptional resource density, abundant marine proteins, fresh water at river mouths, diverse plant resources, and natural transportation networks. These advantages would have reduced subsistence pressure and facilitated knowledge exchange. Under such conditions, innovation could accelerate. Maritime technologies would develop to exploit marine resources. Knowledge systems would expand to track tides, currents, and celestial navigation. Social structures would evolve to coordinate increasingly complex activities. As sea levels rose, these hypothetical coastal innovations would face disruption. Some knowledge would transfer successfully to inland regions. Other specialized maritime technologies would become less relevant and potentially disappear from the archaeological record. This coastal innovation hypothesis offers a middle ground between conventional models and more speculative lost civilization theories. It suggests greater complexity in coastal regions without requiring implausibly advanced prehistoric technologies. It also aligns with emerging evidence from genetic studies. Analysis of ancient DNA shows population bottlenecks and replacement events coinciding with periods of rapid sea level rise, suggesting significant demographic disruption during these periods. Recent paleoclimate research has refined our understanding of how rapidly sea levels rose during meltwater pulses. Evidence from coral reefs, sediment cores, and isotope analysis indicates periods when coastlines retreated by kilometers within single human generations. The most dramatic of these pulses, Meltwater Pulse 1A around 14,500 years ago, saw sea levels rise approximately 16 meters in less than 500 years. Meltwater Pulse 1B around 11,600 years ago added another 14 meters over a similar time frame. For populations living on shallow continental shelves, these pulses would have created observable flooding within human lifespans. A person might witness shorelines retreating by hundreds of meters during their lifetime, rapid enough to seem catastrophic. This realization helps resolve another paradox: why flood myths worldwide describe sudden rather than gradual inundation. From a geological perspective, post-glacial sea level rise was gradual. But from a human experiential perspective, meltwater pulses would have seemed catastrophic. The current scientific consensus acknowledges that while sea level rise averaged 1 to 2 meters per century, it occurred unevenly, with periods of much more rapid change. During peak meltwater pulses, rates may have reached 4 to 5 meters per century. At such rates, coastal communities would face genuine catastrophes rather than manageable transitions. Even sophisticated societies would struggle to relocate infrastructure, agricultural systems, and populations quickly enough to maintain cultural continuity. This understanding bridges the gap between geological evidence and cultural memory. It explains why flood myths appear worldwide despite their geographical implausibility. They preserve memories of real catastrophic flooding events experienced by coastal populations. It also explains curious patterns in early agricultural development. The Neolithic Revolution appears to begin almost simultaneously in multiple locations worldwide around 11,600 to 10,000 years ago, precisely when Meltwater Pulse 1B was forcing coastal displacement. This timing suggests a provocative possibility. Was agriculture not a primary innovation, but an adaptive response to displacement? Did coastal populations, forced inland by rising seas, adapt their subsistence strategies to new environments where maritime resources were unavailable? Recent archaeological discoveries lend credence to this hypothesis. Evidence from sites in the Levant shows communities shifting from marine-focused diets to cereal cultivation precisely as nearby coastlines experienced rapid inundation during Meltwater Pulse 1B. Similar patterns appear in Southeast Asia, where early rice cultivation develops as sea levels inundate the Sunda Shelf. In the Americas, early agricultural experiments coincide with flooding of coastal plains along both Atlantic and Pacific coasts. These correlations suggest catastrophic coastal flooding may have played a more significant role in human cultural development than previously recognized. Rather than a simple story of progress, the Neolithic Revolution may represent adaptation to environmental catastrophe. This new understanding of how sea level rise affected human societies creates a framework for interpreting underwater discoveries. It suggests submerged sites may preserve evidence not just of prehistoric settlements, but of sophisticated coastal adaptations lost during catastrophic displacement. As underwater archaeology advances, we may discover not lost civilizations, but evidence of specialized maritime adaptations, fishing technologies, boat construction methods, coastal management strategies, and trading systems that disappeared when their environmental context changed. These wouldn't represent technologically advanced, Atlantis-like societies, but specialized coastal adaptations developed by fully modern humans responding to their environments with the same intelligence and creativity evident throughout human history. This more nuanced understanding preserves scientific rigor while acknowledging both the archaeological evidence for sophisticated prehistoric coastal settlements and the cultural evidence preserved in flood myths worldwide. It suggests what really happened during the Great Global Flood was neither gradual adaptation nor the destruction of advanced civilizations, but a middle scenario: catastrophic displacement events that disrupted sophisticated coastal adaptations and forced rapid cultural transformation. Chapter 10: Rewriting Prehistory. The true story of the flood. After examining the geological evidence, underwater archaeological discoveries, ancient myths, and genetic data, we can now answer our central question: what really happened during the Great Global Flood at the end of the last ice age? The answer emerges at the intersection of multiple lines of evidence. It represents neither the conventional narrative of gradual adaptation nor speculative theories about technologically advanced lost civilizations, but something more nuanced and ultimately more profound. Between 14,500 and 11,600 years ago, Earth experienced two massive meltwater pulses as the great ice sheets collapsed. Sea levels rose by approximately 30 meters in less than 1,000 years, an average of 3 meters per century. But this average obscures periods of much more rapid rise. During peak meltwater pulses, sea levels rose by as much as 5 meters per century, 50 millimeters per year. On shallow continental shelves, this could cause shorelines to retreat by kilometers within a human lifetime. For coastal communities, these weren't gradual changes, but genuine catastrophes. Settlements that had existed for generations would become uninhabitable within decades. Coastlines familiar to elders would be unrecognizable to their grandchildren. The archaeological evidence confirms substantial human presence on these now submerged landscapes. We've documented hundreds of underwater sites worldwide: stone structures, middens, hearths, and artifacts that once stood on dry land. These underwater discoveries reveal sophisticated maritime adaptations. Stonefish traps designed to work with tidal cycles. Structures positioned to exploit seasonal fish migrations. Settlement patterns aligned with now submerged river valleys and estuaries. What emerges is evidence not of lost civilizations, but of specialized coastal economies, communities that had developed sophisticated adaptations to maritime environments over thousands of years, creating technologies and knowledge systems specifically for coastal contexts. These weren't primitive societies. By the early Holocene, humans had already developed complex technologies: art, music, astronomy, long-distance trade networks, and sophisticated social systems. Coastal communities likely represented the most advanced of these adaptations. When sea levels rose catastrophically during meltwater pulses, these communities faced existential threats. Their specialized maritime adaptations, developed over countless generations, became increasingly unsuited to rapidly changing environmental conditions. The genetic evidence confirms demographic disruption during these periods. Population bottlenecks, replacement events, and migration signatures coincide with meltwater pulses. Ancient DNA shows population movements consistent with coastal displacement. Archaeological evidence from inland sites reveals curious technological patterns following these flooding events. Sophisticated technologies appear suddenly, without clear developmental precursors. Knowledge systems seem to arrive fully formed rather than gradually evolving. For example, early agricultural sites in the Fertile Crescent show evidence of maritime knowledge despite their inland locations. Astronomical systems used by early agricultural societies incorporate techniques useful for maritime navigation. These patterns suggest knowledge transfer from displaced coastal populations to inland regions. Not complete preservation, but fragmented transmission of specialized technologies and practices developed in maritime contexts. Comparative mythology provides the final piece of evidence. Flood myths appearing in over 300 distinct cultural traditions worldwide share remarkable similarities in their core narratives: divine warning, vessel construction, survival, and renewal. These myths don't describe gradual sea level rise, but catastrophic flooding events. Precisely the experience of communities facing the peak rates of sea level rise during meltwater pulses. They preserve cultural memory of genuine catastrophes. When combined, these lines of evidence tell a compelling story. By the early Holocene, sophisticated maritime communities had developed along Ice Age coastlines. These weren't advanced civilizations with impossible technologies, but specialized coastal adaptations. When sea levels rose catastrophically during meltwater pulses, these communities faced displacement, fragmentation, and cultural disruption. Some populations successfully relocated inland, bringing portions of their knowledge systems and technologies with them. Other groups perished, their specialized adaptations lost. Some communities managed to maintain cultural continuity through oral traditions, preserving memories of their ancestral territories and the catastrophes that claimed them. These traumatic displacement events embedded themselves in cultural memory as flood myths. The widespread distribution of these narratives reflects not cultural diffusion, but the universal experience of coastal populations worldwide facing the same global phenomenon. The timing proves particularly significant. Meltwater Pulse 1b occurred around 11,600 years ago, precisely when multiple human societies worldwide began transitioning from hunter-gatherer economies to early agriculture. This correlation suggests a provocative possibility. The Neolithic Revolution may represent not simply a technological innovation, but an adaptive response to catastrophic coastal displacement, inland adaptation by populations who had lost their maritime resource base. Early agricultural communities show evidence of this transition. Many incorporate maritime symbols in their earliest iconography. Their religious systems often feature flood narratives and water deities. Their astronomical knowledge includes techniques useful for maritime navigation. These elements suggest cultural continuity with earlier maritime traditions, modified and adapted to new inland contexts. The Neolithic Revolution may represent not the beginning of complex human societies, but their transformation following environmental catastrophe. This understanding resolves apparent paradoxes in the archaeological record. It explains why sophisticated knowledge systems appear too early in conventional timelines. It clarifies why flood myths share such remarkable similarities across unrelated cultural traditions. It also explains curious technological regressions visible throughout prehistory. Specialized maritime technologies would become less relevant in inland contexts. Knowledge systems designed for coastal environments would require adaptation for terrestrial applications. The evidence suggests not the destruction of impossibly advanced civilizations, but the disruption of sophisticated coastal adaptations, specialized technologies and knowledge systems developed by fully modern humans responding creatively to their maritime environments. This more nuanced understanding preserves scientific rigor while acknowledging both the archaeological evidence for sophisticated prehistoric coastal settlements and the cultural evidence preserved in flood myths worldwide. It suggests what really happened during the Great Global Flood was neither gradual adaptation nor the destruction of advanced Atlantis-like civilizations, but catastrophic displacement events that disrupted sophisticated coastal adaptations and forced rapid cultural transformation. These events weren't just ancient history. They fundamentally shaped human cultural development. The civilizations we recognize as the beginning of history in Mesopotamia, Egypt, the Indus Valley, and China may represent not the first complex societies, but adaptations that emerged after maritime communities were displaced by rising seas. The conventional narrative of human prehistory, with hunter-gatherers slowly developing agriculture, then villages, then cities, may be fundamentally incomplete. It may represent only the visible portion of a longer, more complex story largely hidden beneath our oceans. As underwater archaeology advances, we may discover evidence not just of prehistoric settlements, but of sophisticated maritime adaptations, fishing technologies, boat construction methods, coastal management strategies, and trading systems that disappeared when their environmental context changed. This realization transforms our understanding of human history. It suggests our current civilization represents not the pinnacle of human achievement, but one phase in a longer cycle of development, disruption, adaptation, and renewal shaped by environmental change. Perhaps most significantly, it reminds us of our vulnerability to environmental transformation. The societies we consider the foundation of civilization emerged in the wake of catastrophic climate change. Their development was shaped by adaptation to environmental disruption. As we face our own climate crisis with accelerating sea level rise threatening coastal communities worldwide, these ancient experiences offer both warning and inspiration. They demonstrate both human vulnerability to environmental change and remarkable capacity for resilience and adaptation. The Great Global Flood wasn't myth, but memory, cultural recollection of catastrophic events experienced by countless coastal communities worldwide as the last ice age ended. These weren't divine punishments, but natural processes operating on scales difficult for humans to comprehend. In preserving these memories through myth and oral tradition, our ancestors transmitted crucial information across hundreds of generations. They encoded warnings about environmental change that remain relevant today as we face our own challenges of rising seas and changing climate. What really happened during the Great Global Flood was the catastrophic displacement of sophisticated maritime communities by rapidly rising seas, forcing cultural transformations that would ultimately lead to the agricultural societies we recognize as the beginning of civilization. This understanding doesn't diminish human achievement, but contextualizes it within longer cycles of environmental change. It suggests our current civilization isn't the first to face existential environmental threats, nor the first to adapt, transform, and potentially emerge renewed. As we conclude our exploration of what happened during the Great Global Flood, we're left not with definitive answers, but with a more profound appreciation of the complexity of human prehistory and the extent to which it remains hidden beneath our oceans. The conventional narrative that human civilization began with agriculture around 10,000 years ago, leading to the first cities in Mesopotamia around 5,000 years ago, represents at best an incomplete picture, one biased toward evidence that remained above water. What we're discovering through underwater archaeology, comparative mythology, genetic studies, and paleoclimatology is a more nuanced understanding. Sophisticated maritime adaptations likely developed along Ice Age coastlines, only to be disrupted by catastrophic sea level rise. These weren't advanced civilizations with impossible technologies, but specialized coastal communities adapting creatively to their environments, developing maritime technologies, astronomical knowledge, and social systems specifically suited to coastal contexts. When sea levels rose catastrophically during meltwater pulses, these communities faced existential threats. Some populations successfully relocated inland, bringing portions of their knowledge systems with them. Others perished, their specialized adaptations lost to history. The trauma of these displacement events embedded itself in cultural memory as flood myths, narratives that appear in hundreds of cultures worldwide not because they spread from a single source, but because they preserve universal experiences of coastal populations facing the same global phenomenon. This understanding transforms not just our view of the past, but our perspective on the present. It suggests our current civilization exists within longer cycles of development, disruption, and renewal driven by environmental change, cycles that may hold crucial lessons as we face our own climate crisis. As we continue exploring the submerged landscapes that once housed these maritime communities, we may discover not lost civilizations, but lost adaptations, specialized technologies and knowledge systems developed for coastal environments that disappeared when the waters rose. These discoveries remind us that human history isn't a simple story of continuous progress, but a complex narrative of adaptation to changing environments, of knowledge gained, lost, preserved, and rediscovered as we navigate our ever-changing planet. The story of the Great Global Flood isn't finished. It continues both in our ongoing discoveries beneath the waves and in our current experience of rising seas and changing climate. By understanding what our ancestors faced, perhaps we can better prepare for what lies ahead. If these ancient stories of survival and renewal intrigue you, subscribe to our channel for more explorations of humanity's hidden history and the profound connections between past environmental changes and our present challenges.